factors influencing the composition of milk. The milk composition is affected by, there are many factors. So basically we can divide into the two broad factors. The one is the genetical factors and the other one is the environmental factors. Sometimes the yield of milk and its the composition can be changed because of this the different factors, and the yield as well as the chemical composition is influence on the profitability of dairy farming. So why I am saying that this the yield, when you have the quantity, more and more quantity, then you will get more earnings, as well as the price of the farm gate price will mainly depend on the chemical composition of a meal. So but unfortunately we cannot expect the same composition of milk from a different cows, or sometimes even from the same cow at a different time interval. Early morning we are getting different compositions and the yield, and afternoon maybe the different composition as well as the yield, because the milk is a product of a biological process with an inherited natural variation. So because of the naturally there are variations were there, so that's why we cannot expect the same composition. And basically the fat content is usually shows the bigger variation than the other constituents. The fat is the major one. So now under genetical factors there are two factors. One is the species. So when you have the different species, like now for example you can see in this table, now the women they have the different composition is milk, the mother's milk, and the cow different compositions. Sometimes the goat, sheep, and buffalo, camel, and the pigs, they have the different compositions, especially the fat and the amount of water, maybe the protein or the lactose, the main carbohydrate. So likewise the different compositions were there. Therefore the first factor is the species. Second factor is that within a species there are many breeds were there. So we know that this when you take the Indian breeds, Sindhi Sahiwal, dairy breeds, but when you have this the European, Holstein Friesian, Jersey, Ayrshire, Milking Shorthorn, there are many breeds were there. So within the species, if you take the different breeds, the compositions can be varied. So therefore, you can see the fat content of European breeds. Now, for example, Holstein Friesian, so the low certain amount of fat content is little bit lower than the Jersey. Jersey animals high fat content. But Ayrshire may be the average fat content. So Holstein Friesian, but the yield is so high. But Jersey yield is comparatively low. Yield low, but high fat. Holstein Friesian, high yield, but less amount of fat. Likewise, the breed also is another factor. So the breed producing milk with high fat content produce less milk than those producing milk with a low fat. Yes, I told you that this sometimes the Friesians they produce high yield but less amount of fat. Jersey low yield but high amount of fat. Sometimes the Jersey have the high amount of fat. And the environmental factors, the stage of lactation. So as we all know that this as far as the cow is concerned, the lactation period, lactation is the milk giving period, is around 305 days. Within this 305 days, so we cannot expect the same composition from a milk. The composition can be varied. So different composition is there. So now you can see in this table, now time after calving is the 0. Just after the pasteurization or the calving, high amount of protein is there. That is because of high immunoglobulins were there in the milk. That's why the total protein, albumin is high. Albumin is the way immunoglobulins are the kind of albumin. So therefore albumins are high, but total protein is high, but fat is also high. But once it gradually it will change it. after 1 day or the 2 days or 3 days time, 3 to 4 days. After 4 days, it will convert just automatically. It comes to the normal milk composition. So therefore, you can see the protein levels and the fat is the normal fat content after 3 to 4 days. Now this is the 2, 3, 4 days is here. 4 days, after 4 days, it's almost normal milk. So the stage of lactation. So you can see this is the stage of lactation within the 305 days. Initially, within first month, we will have a high yield, peak yield is there. So then after that, gradually it will decline throughout this period. Gradually it will decline, the yield. The composition also be varying. Now this is the composition, the lactation period. Blue is the yield, gradually declining, and the fat content is comparatively increasing. Somewhere around up to 4.7 or things we can increase during the lactation period. Here also the figure shows that the fat variation as well as the lactose, main carbohydrate, and the protein variation within this lactation period. This is the stage of lactation, and this is the solid amount, and this is the just after the pasteurization, 0 days, the time of carving, and then the 305 days is then after that dry period. So within this period, these main constituents will vary as we shown in this figure. And the other one is the age of the animal. Age of the animal and stage of lactation is different. Now this is age of animal means after first pasteurization, we call the animal in the first lactation. After first pasteurization, after the delivery of first calf, they are the cow in the first lactation. After second delivery, they are in the second lactation. After third delivery, they are in the third lactation. Normally, the yield will increase within the third to fifth lactation. Highest yield is there, third and fifth. Then after that, gradually it will decline. Right? So then the age of the cow is another important factor of this variations. So the milking practices, these are the most important thing. The number of milkings. You all know that in most of in our country, so the milking is we have done it in twice a day, early morning and evening, duration between 2. But the thing is now we have to consider about the method of milking as well as the efficient milking and the number of milkings. So if you can increase this number of milkings up to the 3 times a day, so then we can increase the total milk production or the yield per a particular day by 25%. We can increase it. But the thing is, we have to keep it in mind, much shorter intervals between the morning and evening milking than between the evening and morning. So after evening and morning, we have the gap or the much larger interval, but shorter intervals between the morning and the evening milkings. So we can milking at 12-hour intervals, the variation in fat content between milking would be negligible. They have shown that even if you can have it milking for a 12 hours interval, sometimes, so it's a negligible amount. And the completeness of milking is very important because as you all know that the milking methods, there are many milking methods. One is we call as this figure shows that this is the full hand milking. So we have to bend the thumb and by using the other 4 fingers, especially the 3 fingers and the top one, we have to squeeze we have to tie the teeth, and from the other 3 fingers we have to squeeze it, then the milk will come out. This method is we call as the full hand milking. But likewise there is another method, so we have to bend the thumb and tie up with the teeth. That is called the knuckling method. And this is the last method here, the stripping. Because even if you have done it from the full hand and the knuckling, sometimes a certain amount of milk will retain in the cow's teeth. So therefore, the particular milk, the last few drops of milk, which contain high amount of fat. So therefore, by having the different mechanism like stripping, we have to take out all the milk retained in the teats. We have to take it out. So then we can have the appropriate the composition of a milk. Otherwise, the fat content can vary. So one is the full hand milking, other one is the knuckling, and other one is the stripping. Stripping will remove the last drops of the milk retained in the teat, because which contain high amount of fat. So the other thing is the milking also, we have to do the milking within 8 minutes of time, because it's governed by the hormone oxytocin. So normally 8 minutes. So if you fail to get all milk within 8 minutes, so then there we have to have different mechanisms to induce the animal again, right? So then the feeding practices, feeding is another important thing. We all know that this the underfeeding. Sometimes the animal, dairy animal, they require the amount of feed depend on their body weight. So the body weight into 10% from the average quality grass. Average quality grass means if it is a fodder or the other type of a pasture, we assume that average means 20% of dry matter is there. 80% water, 20% of dry matter. That is called average quality grass. If it is average quality grass, we have to feed the animal with 10% of their body weight. If it is a roughages like straw and other dry hay or like things, so then the 2.5% of their body weight. But if you feed it lower than that, so then the underfeeding. So then they reduce the lactose, as well as then the amount of fat is increased, but the yield is low, as well as the other constituents are low. Feed rich in fat may increase the fat percentage, yes, and the more roughages, fat will increase it. And sometimes the feeding with compounds and with sharp flavors. So milk also acquire that flavor, because now supposing we assume that if you fed the animal with the feed which having the flavors, like we assume the ripened jack like sometimes if you fed the animal. So then the milk also will have the same flavor sometimes. It's obvious that because having sharp flavor, so it's a biological process. So then after digestion, it will absorb into the body through the fat. It will comes to the milk. So the individual variations, even from the same animal, maybe the calves, the first calf in one and the second calf in another calf, or sometimes if you have the twins also. But variations may be there. We know that we're not in the, especially in the cows, but also in the goat, the twinning rate is high, and pigs, the mother pig we call sow, delivered basically 8 to 12 piglings at a time. So that is the all are in the same the piglings, the same delivery. They are in the same delivery. So the individuals within that. But when you have the individuals, the variations may be there, different variations. Like humans also, the twins are there. Sometimes the twins, identical twins are there. Sometimes the twins have the different body characters and the figures and variations. Like individual variation. Same breed with uniform environmental conditions, but sometimes the considerable variations occur, especially in the fat percentage and the other constituents. So the condition of the cow. During the calving, if the cow is very healthy, so then the animal gives 25% more milk than the weak cow. So sometimes the healthy and the weaknesses you measured from by looking at the animal, that is not exactly because now the people, the farm management, they are looking at the body conditioning score. It is something else by looking at the different the fat depositions at the different places and the body shapes and everything. There are different methods to measure the body conditioning score. If the animal having the high body conditioning score, so then the hacha animals and the healthy, so then they give the more yield than the other animals. Disease status. We know that in the dairy animals, the most prevalent disease is the mastitis. Mastitis. Now you can see if the animal is suffering from the mastitis, it is a It's caused by the multiple organisms, not a single one. So then a lot of problems were there if they're suffering from the mastitis. Sometimes it's called the other infection and decrease the yield, and lactose, fat and casein percentages are low. Only thing is increase chloride content. Sometimes increase the soluble nitrogen if the animal is suffering from the mastitis. But normally, where we don't take the mastitis affected the meal, we don't take it for the consumption or the other processing things. We have to discard it. But even we have to prevent the mastitis. That is the most important thing. Otherwise, once the animal is suffering from the mastitis, it's very difficult to cure it. So other diseases, the foot and mouth. Now you can see the legs, foot, the lesions were there, and the mouth also there are lesions were there. So therefore, very difficult to walk and difficult to eat also. So that is called the foot and mouth disease. So then it's be a very big problem in the farm industry. If they are suffering from these diseases, we have to eradicate. So that is another disease. And the other one is the season. When the temperature is high, yield will decrease automatically. We know that high temperature, yield will decrease it, and fat percentage will increase it. The season. But the thing is, you have to be careful on the other most important thing is the management practices. Now, I will give you one example, the Holstein Friesians. Now, they are the European breeds. Now, these Holstein Friesians in Sri Lanka, they gave the highest yield maybe somewhere around 19-20 liters per day. But the same animal in the Almara, sometimes they yield around 40 to 60 liters per day. That is because of the management practices. Even the climate, the conditions they provided for the animal, the feeding, and the other management practices. So that's also be a reason for this yield and the composition. So then the next thing is the collection and reception of milk. Collection of reception. So during this milk collection, let down process, initial step is, we know that there is a different procedure is there. Basically, I told you that this the animal. The cow will bring it into the milking parlor, right, for milking purposes. So then initially we have to tie up the animal, then we have to give them a concentrate feeds, and then after that we have to clean the especially in the udder area, we have to clean it by using the slide warm water, lukewarm water. We have to clean it, and then by using the dry towel we have to clean it in the udder area, especially teeth and everything. Then after that, if it is a small farm, or if you have one or two animals or few animals, so before that we have to tie up this the rear legs also and the tail. That is most important. But in their large farms, they have a special condition, so therefore you don't need to tie the legs and the tail. But other conditions we have to do it, then you can obtain the clean milk from the animal. So after that, then after that we have to check whether this milk is the animal is suffering from the mastitis, or whether this mastitis affected milk. We have to check it. That is the first test is we call as CMT test. CMT means Californian mastitis test. Californian mastitis. For that we have a special 4 compartment, 4 cups. 4 cups were there because the cow, they have the 4 compartments. 2 compartments in the right side and 2 compartments in left side. 2 compartment maybe the 4 and rear 2. That means altogether 4, right? Left side 2, right side 2. One is the 4 compartment, 2 and rear 2. So that's why we have a ABCD 4 cups were there for the each teat. So then we have to take a few drops of milk into the cup separately, from one teat for 1 cup, other teat the other, likewise. So then after that we have to add the Californian mastitis region. When you add the Californian mastitis region, maybe the purple color is there, and sometimes you can see the cloudy appearance for there. Cloudy appearance for there. So if we have the cloudy appearance, so then we know that is early stage of a mastitis. Cloudy appearances for there. So then we can detect whether the animal is suffering from the mastitis like thing. If you don't have this the CMG, which is little expensive, we need chemicals. poor farmers, they cannot afford for that. So then we can use the strip cup test. Strip cup means you don't need the 4 cups, but the same, but the black background is the black background. From individual teeth, we have to take the few milk, and if the animal is having the mastitis, you can see the clots were there. Clots were there. Or sometimes you don't have this type of a strip cup, or even you can take whatever the cup and you can have a black color cloth, and then you can take the milk into that cloth. So then, even if you don't have this systems, cups or whatever it is, poor farmers sometimes, if we are just take milking parlor, milking place is whether they have this cement in the floor. So if you have take the milk into the few drops into the floor, so then you can observe whether there is any clots. That is another option. So the milk collection, so I told you that is initially you had to tie up, introduce the concentrates, and then we have to tie up the rear legs and the tail, then cleaning, and then after that by manually we have to take up the milk. One is the by manually, or sometimes by mechanically. If we have a few number of animals by manually, or the maybe the few little number of animals were there, the mechanically also by having portable machines or other systems. Now here you can see this is the large farms, they have it, this type of sophisticated one. So the milk, so after let down, milk will go to the bottle, then you can measure the quality, quantity, and then after that the chilling, this is the plate heat exchanger, chilling, and pass it through into the collecting tank, chilling tank. While chilling, the agitation is done, so you can keep it until the collections. Oh, this is the mechanism, right? Take the milk, and then again sometimes so they will send it to the chiller tank, and a particular tank itself the cooling as well as the agitation is done, cooling and agitation here. Or sometimes there are other farms like I took this picture from this Bopatala farm. Uh, yes, Bopatala. So they don't have the large bottles to measure the milk, but here they have very small ones. So if they have the certain quantity, so maybe 1 milliliter of milk will collect into this tube. So if you know the 1 milliliter, if you can measure this amount, based on this amount, they can calculate how much they yield it within a particular milking time. So that is another mechanism for that. So we can uh, have it, we can collect the milk. And this is the sophisticated, as I told you, that herringbone system. So you don't need to tie up the animals, but animals may be in the higher altitudes, but the peoples are in the bottom. So then they can clean it very easily. No harm at all. So never attack onto the people. So they just clean it and then just do the milking. This is called the herringbone system. And this is another advanced method. So in the different countries, they have different mechanism for the milking parlor, different mechanisms. So this is the methods I told you, that this is the full hand milking, this is the stripping method for the milking method. And then the collection of milking, we know that is the throughout the country in the different companies, they have it a different milk collecting centers. For example, now this is for the Highland factory, they have it throughout this country. Right now in the north as well as the other part of that, also there are many collecting centers were there. And unlike in the other industries, the dairy industry, they have a very special unique character. Normally the dairy farmers, among these dairy farmers, they have the farmer management societies, maybe 50, 100 or 100 farmers get together. They form the society. Within the society, they appointed the secretary as well as the other management staff also. Paid person is only the secretary. He or she will take the milk from the other farms also in that, and they while taking this milk, we check the quality and as well as the quality as well as the fat and SNF contents, because the price is determined mainly from the fat as well as the SNF and the total volume. They measure all these things and then they will collect the milk and they will just keep it in the chilling tanks. And if they don't have it, after collecting this, they will send it to the chilling centers. And chilling centers, they will keep it until the factories or the processing factory, they will send their bowsers and collect from the chilling centers. That is the milk collection. So this is the, for a delivery, they have a special, this type of a can is there, maybe 10 gallons or 45 liters with a large can, or sometimes the very small cans also there. So they will just bring it into the collecting center from this can. And the bowsers are the insulated compartments were there inside the bowser. So they maintain the temperature below 4 degrees, around 4 degrees or lower than that. And the agitation is there. Inside is the bowsers, insulated tanks were there. In the chilling center, so they keep the milk cool, normally around 4 degrees. After taking, immediately they will cool it. And the agitation is done in the chilling centers, milk chilling centers. So while you are taking this milk, so you have to check the quality. So how we are going to check the quality? The test performed at this stage we call as the flat form test. Flat form. In a train also, we know that in the station there is a place that will facilitate to enter into the train. That's why we call flat form. Likewise, this is also flat form, like which will facilitate to take the milk, these tests, because of the result. Based on these results, they will decide whether you are going to accept or whether you are going to reject it. Initial test, sometimes the person will, supposing if you are appointed as the quality controller in a dairy farm, dairy industry, so initially you have to check the clot on boiling or alcohol test, not the other test. You should not perform other. First, you have to do the clot on boiling or alcohol. If you don't have the furnace or other things, so then the alcohol test. Clot on boiling means you have to take the small quantity of milk and boil it. While boiling, you can see the clots, because that is, if the acidity is so high, so then the milk will clot it. So then we have to reject milk. Or otherwise, you have to do the alcohol test. Alcohol test means you have to take the 1 milliliter of milk into the test tube, and you have to add, some people they add 70% of ethyl alcohol, but sometimes 68% of ethyl alcohol, the same volume, into the tube, and you just mix it and see through the wall whether there is any clots. If there is any clots are seen, so then we have to reject the milk. Then the next one is the specific gravity. Specific gravity, we can measure the specific gravity by using the lactometer. Now this is the lactometer. It's a graduated one. Normally the lactometers graduated in the different way. Sometimes direct, we can measure the direct readings, or sometimes you have the graduations like 0, 10, 20, 30, 40, like that. So that graduations were there. But sometimes you have the 1, 1.01, 1.02, like that graduation. So then it's easily, directly we can take it the measurement. But if you don't have that graduation, so 10, 20, 30, so then there is a small calculation. Calculation is the calculation, the equation is 1 plus A divided by 1000. A divide 1000 plus 1. Supposing we assume that the A is the reading of the particular lactometer. We assume reading is 32. 32 divided by 1000 means 0.032. When you add 1, 1.032, then the specific gravity. So that is the way. But when you just see the lactometers, most of the lactometers are graduated at the 20 degrees centigrade. So therefore, we have to check the temperature of the milk at that time. If the temperature, based on the temperature, so there is a correction factors are there. You can see in according to the table. If the temperatures are different in the milk, 20 the 0, because that is calibrated at 20 degrees, that's why the 0. If the other temperatures, milk is in other temperatures, so we have to add or we have to deduct the values from this these values from the your value, right? So the ideal method is, even if you have the milk, you just heat it up to the 40 degrees and cool it into the 20 degrees and take the milk into the measuring cylinder. Slowly you just insert the lactometer and take the reading. Now this is the way you have to take the reading. Now you can see here, you have to take the reading very carefully. Now this is the reading. This is not this value. You have to see this is the value, right? Now this is the value you have to take. So then you can take the value. We know that this is a fresh milk. The specific gravity is 1.025 to 1.02035. 1.025 to 1.035 within that range. But basically, the fresh milk 1.028 is the exact value. But within that range, it's okay. So now here, if you add more and more water, what will happen? The reading is more closer to the 1, because more water, then the reading is closer. Specific gravity of pure water is 1. So therefore, the value will reach to the 1. That's why you have to be very careful on that. Then the fat content. How we are going to measure the fat content? The method is we call as the Gerber method or Gerber method. Gerber or Gerber method. Now here the instrument is we call as the butyrometer, and so here we need the butyrometer. Now here the butyrometer, and we have the rubber stopper as well as the small pin is there. So we have to insert the rubber stopper by using this pin, right? So then we have to keep this butyrometer like this way in a rack, right? So then initially we had to add the 10 milliliter of Gerber sulfuric, not the other sulfuric, concentrated or diluted. Here we add Gerber sulfuric. Gerber sulfuric is 90% of sulfuric. 90% sulfuric is the Gerber sulfuric. 10 milliliter of Gerber sulfuric we had to add into the butyrometer. Then after that we had to add the milk. Amount of milk is by using the milk pipette. Here the milk pipette is there. That is we call as the milk pipette 10.94 milliliters. 10.94. Special milk pipette is there. 10.94 milliliters of milk we have to add it. Then followed by the 1 milliliter of amyl alcohol. Amyl alcohol. When you add all these three components, you can see the black color is there. So then we had to insert the stopper, but just keep it in mind, the two things we have to keep it in mind. Likewise, in the previous case, if you want to measure the fat, you have to heat the milk into maybe around 40 and then you have to cool it down and mix well. Then fat will all mix well. And then you have to take the 10.94 milliliters. When you add the milk and the other chemicals into the butyrometer, we have to take precautions not to wet this neck region, right? Normally we send the acids and the other things through the wall, but here we don't send it through the wall, because once it gets wet, we cannot insert this stopper into the butyrometer, right? So therefore we have to avoid that, and then after that we have to insert the stopper and carefully you have to mix it. Turn upside down and mix well. You have to be careful because the heat will generate here. So then we have to mix well. And then after that, we have to keep it in a centrifuge machine. The speed is 1100 RPM for 5 minutes. After 5 minutes, you have to take up this tubes from the centrifuge machine and keep it in a 65 degrees water bath. So then you can take the reading. Now here the yellow color is the fat. Now here the lower value and the upper value. So the difference is the difference from the upper to lower. Then you will have the fat content. You direct reading. But sometimes this layer may be here below the zero level, fat layer. So then by using the pin, special pin is there, I told you, to insert the stopper. So you have to insert this stopper in the bottom of the stopper, and you have to push it. When you push, this fat layer will comes to the top. So then once it reaches to the zero, the bottom value will reach to the zero, then you can read the upper one. So then that is the amount of fat. So this method is we call as the Gerber method. Then the SNF, so there are two methods. By using the equation, we can measure the SNF, or otherwise, if you know the fat content, and if you have the, if you are working in a laboratory, if you have a oven, so then you can measure the total solids, then total solid minus fat, then you will have the SNF content. Or otherwise, we have equation that we can calculate the total solid first, and then the value will from the total solids. If you deduct the fat content, then you can get the SNF. Now here 0.25 L, this is a lactometer, corrected lactometer reading, and then 1.2 F, F is the fat content, plus 0.14, 0.25 L plus 1.2 F plus 0.14, then total solids. Total solid minus fat, we will have the SNF. Or otherwise, by having the direct SNF percentage is 0.25 L plus 0.22 F plus 0.72. You can get the direct SNF. But the thing is, I have done experiment by using these two equations as well as the other method. We calculated, but small differences are still differences are there. But the scientists, they have introduced this method. But anyway, the ideal is that if you have oven, you have to measure the total solids and the fat separately. Then you can have the SNF that is more accurate than this method, right? Or there's other one is the total solid. This is the density, and 122 F is the fat, 0.72. Both methods, so we can calculate it. Why this SNF and fat content is important? Now you can see in this table. This is the table. Each collecting center, so they have the table, or they have it. Now in the here, x-axis is, we can see this is called the fat content, and y is we call the SNF percentage. Based on the amount of SNF, now starting from 8, 8.1, 8.2, 8.3, 8.4, so on till up to 9.4, and the fat starting from 2.5 to 6.8. So depending upon the amount of fat and the SNF, the price can be varied. Now this is very all for one, but right now with a little bit of deviations for there, the amount. But anyway, just keep it in mind, the method is same. Based on the fat as well as the SNF, price will determine. So therefore, the farm gate price mainly depend on two factors. One is the fat percentage, other one is the SNF percentage, and the total income depend on these two factors as well as the yield also. Total income of the farmer depend on the yield also. So then the dye reduction test. Now this is the dye reduction test. Two tests were there. One is called the reducase and methylene blue. Now these two tests were especially for the to detect the microbial quality of the milk. Microbial quality of the milk. So as you all know that the microbial content, amount of microbes in a present in a food sample, we can measure by having the plate, by using the Petri plate method, incubation in a Petri plate. But unfortunately, the Petri plate, there's a traditional method, the plate which takes nearly 24 hours to 48 hours to get the results. But for example, the farmer, they will bring their milk into the factory or the collecting center, but we can't ask farmers to wait 24 to 48 hours until we get the results from the plate count method. So therefore, the scientists, they thought to have a quick method, and they introduced the two methods. One is called the reducase method, other one is the methylene blue reduction test. So those are dye reduction. Here they use the two dyes are redox dyes. The color will change based on the oxygen concentration. So oxygen concentration is high, so then the color is initial color. But if the oxygen concentration is less, then the color will change it. Oxygen concentration less means if there is more microbes, they will take up the oxygen from the milk. So because of that, now the initial color will change. That's what happen in the dye reduction test. Now resasurine, what you have to do is you have to take the milk and you have to mix well and take 10 milliliter of milk into the tube, and you have to add the 1 milliliter of resasurine solution. And then you have to close the tube with the sterile stopper and mix gently. And you have to observe the color changes after 10 minutes or sometimes 1 hour or 3 hours. But mostly 10 minutes is the method. That is, toolkits are available. After 10 minutes, you can observe the color. Now, when you add the resasurine into the milk, initial color is blue. If the color persists blue after 10 minutes or 1 hour or 3 hours, so then that which indicates that milk is excellent. So then we have to accept. So if the color is light blue after 10 minutes, then very good, then still we can accept. The color is purple, then good, still accept. Sometimes the purple pink or light pink, then it's a fair or poor, but we can separate. We can take the milk for other purposes, like processing purposes, we can use it. But if the color after 10 minutes, if the blue color will change into the pink color after 10 minutes, then the milk is bad. Or white, then very bad. We have to reject the milk. So then we have to reject the milk. So color will change accordingly. You can see the blue color, then the pink. Quickly it will after 10 minutes will change. Based on the color change, we determine the amount of microbes. This is not exactly the number of organisms we cannot count from this method. This is a qualitative method. Qualitative method, by using the color change, we estimate the quality of the milk. So second test is the methylene blue dye reduction test. Methylene blue dye reduction, little bit of difference of this. We have to take 10 milliliter of milk into test tubes, not a single, maybe many tubes were there, and then add 1 milliliter of methylene blue solution into each tube. Then we have to cap the tubes, and then after that we have to invert the tubes 25 times to mix the two solutions. So then the milk is blue color, and keep it in a water bath for 37 degrees for 5 minutes. Then after 5 minutes we have to remove the tubes and invert them again. We have to mix it, and again you have to keep it in a water bath. Then after that, every 30 minutes interval, we have to observe the color change till up to 6 or 8 hours. But it takes 8 hours, 6 or 8 hours. But resasurine only takes 10 minutes, maximum 1 or 3 hours, but generally 10 minutes. But here 6 or 8 hours. We have to time, we have to take the tubes and we observe the color change. So we measure the time taken to change this blue color to white. That's what we have observed here. Initially, blue color is the milk. Once you add the methylene blue, milk will turn into blue color. We'll measure the time taken to change this blue into white. Now, within 20 minutes or less, if the color will change blue to white, then we estimate 20 million of organisms were there, approximately. The color change, the time taken to change the color 20 to 2 hours, 4 million to 20 million organisms. 2 hours to 5.5 hours, 5 lakhs to 4 million organisms. 5.5 to 6.5 hours, 2 lakhs to 5 lakhs organisms. 6.5 hours to 8 hours, then the less than 1 lakh of organisms may be there. So this is the estimation. We roughly estimate the amount of organisms based on the color change. So these two methods we can use, but mostly the people, they like resasurine because resasurine is more preferred than the methylene blue, because resasurine will take only 10 minutes, but methylene blue dye reduction, it will take somewhere around 6 hours to 8 hours. Then the other measurement is the titratable acidity. Titratable acidity, what you have to do is you have to take the 9 milliliter of milk into a conical flask. We take 9 milliliter. Even if you wish, you can take 25 or 50, whatever it is. But if you use 9 milliliters, so it's easy for the calculation. That's why we are taking 9. So 9 into the conical flask, and we have to add few drops of 1% Methylene, and then we have to titrate with in a burette 0.1 N sodium hydroxide. 0.1 means N divided by 10 sodium hydroxide. Then the titratable acidity is equal normality of sodium hydroxide into volume of sodium hydroxide into molecular weight of lactic. Now we are measuring this titratable acidity as a lactic acid percentage. So therefore molecular weight of lactic acid divided by 1000 into 100 divided by the amount of milk we are taken for this 9. Molecular weight of lactic acid is a 90. 90 divided by 1000, right? In a 1000 is in bottom. Now 90 into 100, so 1000 into 9, so we can cancel out. So then the volume we don't know, and N is N divided by 10 because 0.1. Then N divided by 10. N divided by 10 means V divided by 10. So if you use this volume and this concentration of sodium hydroxide, only you have to measure the volume you need, amount of sodium hydroxide needed for this titration, that is V. So if you know the volume divided by 10, you will have the titratable acidity. Normally the fresh milks, the titratable acidity as a lactic acid percentage, it's range from 0.1 to 0.18. It's a normal fresh cow milk. But if it is a less than 0.25, milk can stand pasteurization and then should be accepted unless other special requirements are later. So we have to accept till up to 0.25. But the titratable acidity is greater than 0.25, then we have to reject the milk because during the pasteurization, so we can see the clots. That's why we have to reject it. So this is the way we have to accept the milk. If these parameters are okay, we can accept. Once you accept the milk, now we have to have the chemical storage. Storage in the factory level, the storage, there is this type of a large bins were there. These are we call as the silos. The capacity of the silo can vary, maybe 25,000 liters till up to 100,000 or 150,000 liters per each tank, or 80,000. Different capacities were there. But most important thing is we had to agitate. So while keeping in the milk, we have to agitate the milk. That is a temporary storage. So what are the different methods of milk preservation during the storage? First one is the cooling. So if the milk is not collected within 2 hours, it needs to be chilled to less than 8 degrees for a daily collection, or less than 6 degrees for a longer storage period. So if we keep it for a longer period, we have to keep it less than 6. So if the daily collection less than 8 degrees are okay. Within, if we are not going to collect it within 2 hours, so then we have to cool it. That's the cooling. Then the second temporary preservation is we call as deep cooling. If milk is to be stored for a longer period, so then the deep cooling, like 2 degrees centigrade is recommended. So then it is possible to store milk for 7 days at 1.2 to 2 degrees, provided that the initial quality is excellent. If the quality is excellent, if you keep it in a 1.2 to 1.5 to 1.5 to 2 degrees centigrade, so easily you can keep it for nearly 7 days in a silos if you deep cool it. Normally the holding milk for a long days it's not suitable. We are not recommended, but normally we can keep it for few days. Then the other method is the activation of lactoperoxidase system. Activation of lactoperoxidase system means now milk naturally which contain enzyme. That enzyme is lactoperoxidase, but naturally present in milk. Now this lactoperoxidase, normally the content is very small, but it is in the inactive form. But it is a bacteriostatic effect is there, bacteriostatic. Bacteriostatic means not the bactericidal. This is bacteriostatic. Static means inhibit the bacterial growth. So the bacterial statics effect in the presence of two factors. One is the hydrogen peroxide, other one is the thiocyanate. If the presence of hydrogen peroxide, so the thiocyanate is lactoperoxidase enzyme will activate. But this hydrogen peroxide and thiocyanate naturally present in the milk, but the amount is very small. Therefore, lactoperoxidase cannot activate. So therefore, what they do is they add small quantity by purposely into the hydrogen peroxide and thiocyanate into the milk to activate the system, and then it has the antibacterial effect. What will happen because of this? Now, with the presence of hydrogen peroxide, this lactoperoxidase enzyme will act on the thiocyanate and it will convert into the hypothionous acid. Then this hypothionous, because of the milk pH, it will dissociate into the hypothiocyanate ions. Now this hypothiocyanate react with the free sulfhydryl SH groups. So from where we can find these SH groups? So these SH groups are important to stabilize the structure of protein. Proteins, SH sulfhydryl groups are there. So then this hypothiocyanate will bind with the SH, and once it bind with the SH, they are inactivating several vital metabolic bacterial enzymes. Now the SH will bind with the hypothiocyanate, so therefore it will block some vital bacterial enzymes and consequently blocking their metabolism. That will interrupt the metabolism, so therefore microbes cannot multiply. That's how they control the microbial growth. Then the fourth temporary preservation method is thermization. Now this is the method practiced by the most of the industries right now. Right? Thermization, different names, pronunciations, but the thermization is used to extend the pre-pasteurization storage life of a milk. Pre-pasteurization. Now thermization method, the heating milk with the continuous flow to 57 to 68 degrees, in between 57 to 68 for 15 seconds to 30 seconds. Now supposing you might have that 68, we know that 63 degrees is the pasteurization, but 63 for 30 minutes, but here 15 seconds to 30 seconds. So therefore below pasteurization. Now there is a thumb rule in the dairy industry. We never pasteurize milk more than once. Within this processing operations, only once will pasteurized or sterilized. We never do it repeatedly, because if you practice repeatedly, then the quality will decrease it, nutritional values. So therefore, in the industries, we pasteurize only one time. So now thermization is below pasteurization. 57 to 68 degrees the temperature, but 15 seconds to 30 seconds. Right? So then we know that this term before thermization, we had to clean the milk from the standardization process and clarify. So then after thermization, we have to chill the meat and we can keep it in the silos for several days. Thermization is normally done in a dairy factories, immediately after reception. So then followed by the cooling, deep cooling. So then we can keep it to nearly maximum up to 7 days before processing without there being a major impact on product quality. This is the thermization. So the fifth one is the carbon dioxide incorporation. Carbonated beverages are there, carbon dioxide incorporated. Likewise, milk also, the addition of carbon dioxide has been shown to lengthen the storage period of milk held at low temperatures by around 3 days. When you incorporate carbon dioxide, milk also contains water, and the carbonate ions are there, bicarbonate ions are there. Those are toxic to psychotrophic bacteria. The bacteria which preferred low temperature is very toxic for that. Then we can, around 3 days, we can increase the shelf life. But the carbon dioxide can be removed under the vacuum operations. So then we can remove the carbon dioxide. Therefore, nothing to worry about it. So therefore, the temporary preservation, there are 5 methods: cooling, deep cooling, activation of lactoperoxidase system, thermization, and the carbon dioxide incorporation. Out of these 5 methods, the most commonly practiced method in Sri Lanka as well as the other countries, the thermization, and followed by deep cooling. So that's all for the lecture. So we have done it. The next one is the building blocks of the unit operations.